Okay, so here is the basic solar setup, the simplest one I could make. There's a solar panel here under my sun simulator, just a halogen bulb. And I have my lead acid battery here and my CD player. So, piece of cake, 12 volt solar panel, or 15 volt solar panel. .12 volt CD player, 12 volt battery. The solar panel is 15 volts, which means at its maximum, it'll charge up this 12 volt battery, which likes to be charged up to 15 volts. Now, there's something interesting, a problem with this setup. Everything is very simple here. Everything is in parallel. The positives are all connected together, the negatives are all connected together. And what we can see here is this is the current going into the battery. So if you look up, 153 milliamps going into the battery, and here's the current. Here's the current going into the CD player, 250 milliamps, give or take. So let's look at what happens if I turn off the power. So if I turn it off, here's the power coming from the solar from the solar panel to the battery. It's actually negative, which means that power is going from the battery into the solar panel. And that's called reverse current. And that's actually a waste of energy. That's energy leaving my battery for no good reason. It's driving my solar panel backwards. That's the reverse current you find in any diode, and in this case, it's a reverse current in my solar panel. Now, that's not a huge amount of power going out. 8 milliamps is not a ton. My panel has 1,000 times that capacity in milliamp hours. So I could run for 1,000 hours just driving this panel backwards. But I don't like it. It's a waste of energy. It shouldn't have to happen that way. So there's got to be a better way around it, and there is. It's called a blocking diode. So let's take a look at that next.